How's it going, guys? This is the Math Base. Do you know how to solve these trigonometric ratios? Sine pi on 3, cos pi on 2, and tangent pi on 4? If you don't, that's okay. Most of you have probably done this with degrees, but these problems use pi and radians. So they are somewhat different, but let's work on these together today and figure it out. Pi on 3 and pi on 4 are both acute radian angles, so we will need our trusty special triangles for these two problems. And pi on 2 is quadrantal, so we need our unit circle to figure that out. If you're not familiar with these concepts yet, or with pi or radians, then please watch my videos explaining how those are done first. I've linked it in the description, but you can also find them on my trigonometry playlist. Alright, let's get to work. First up, we have sine pi on 3. Since most of us learned degrees before radians, we're better off converting the angle to degrees first, selecting the correct special triangle, then using SOHCAHTOA to solve it. Now, I love pizza, so this is just a thing I like doing when I see pi in maths. Since pi is half a pizza, I would draw a semicircle and split it into 3 slices of pizza. Now I can see how big pi on 3 is. I find this exercise really helpful when it comes to larger radian angles like pi on 3 or 26 pi on 3. And just like pizza, it doesn't take long before I start to see it in my head. Anyway, when you convert pi on 3 to degrees, you can either use the formula and multiply 180 degrees over pi, or you can just take a third of 180 since we're only after a third of this semicircle. This gives us 60 degrees. So now we know we're working on sine 60 degrees, which means we should use the 60-30 special triangle to work out SOHCAHTOA. Since we're working with sine, we would pick SOH, which is the opposite side over the hypotenuse. So sine pi on 3 is root 3 over 2. It feels like an extra step converting, but one of the only times I ever find degrees more useful than radians is with the special triangles. For most other problems in trigonometry, it's much more natural to use radians. Let's try out the next one. Cos pi on 2 has a different denominator, so let's split our semicircle into 2 halves. Each one has a right angle, so it must be 90 degrees. You could say we're working out the problem for cos of 90. So we're dealing with a quadrantal angle. If you want to be a pro at drawing the unit circle, always do it in full detail. Once you have it, plot the point at 90 degrees and pick out its x value. The reason for this is because cosine is represented by x on the x-axis. So we can see that cos of 90 or cos of pi on 2 equals 0. Done. Let's try the last one. Tangent pi on 4. We'll get a proper pizza this time. Split your semicircle into 4 slices, and that's just like half a regular Domino's pizza. They sometimes call it a large pizza, but I don't understand why. Maybe one of you can comment below and explain this to me. Sadly, no matter which way you cut it, whether it be by formula or instinct, you must divide 180 by 4, and some students can find this difficult. My favorite way to work it out is by halving 180 to 90, then halving 90 again to give me 45. Using the 45 triangle and TOA, we see the answer come out to be 1 over 1. So tangent pi on 4 equals 1. And that's how we find all 3, but if you've seen my videos on quadrantal angles, special triangles, and exact values, you'll notice the only thing different here is that we converted radians back to degrees before working on the problem. And with regards to the pizza slices, here's what they look like in their entirety. Most of the time, you'll be dealing with variations of pi on 6, pi on 4, pi on 3, and pi on 2. And their fractions around the pizza look like this. So, for example, if you want to visualize 7 pi on 6, then you shade in 7 parts. If you drew it right, you will easily see it go past halfway, meaning it's in the third quadrant. You can do something similar with the others and use the special triangles and cast system from there. It all comes down to your denominator. Pi on 2 is different because it is quadrantal, so the unit circle will help you figure out which value you need. If you're stuck on any of these ratios, let me know in the comments below and I might make a video for the work solution. As mentioned before, to do most of this stuff, you will need to watch my other videos which explain those principles, and the best way to do that is to go straight to my trigonometry playlist and navigate from there. So I hope this video was fun and helpful for you guys. Remember to like and subscribe for more content coming your way every Thursday. And ring the bell. You might be the first to watch the next video. Thanks guys. See you next time.